Hey, so Reese, I know that you are doing something to train for being a seasonal firefighter right now, which is awesome. What a fantastic way to get some summer money, better than flipping burgers. But missed you the last couple of days. So let me take you through a little bit about what's been going on in class. I thought about doing something else. I figured it's easier to send you a video message. So anyway, let's check out something that we have over here. So what we did in class, I think you're seeing the right thing. Let me stop this share. Let's redo this. Let's make sure that I'm sharing the right thing. In class, we went through a document in Google Classroom right here. These were the notes that we dealt with right here. These are the notes that I'm pointing to right here. And I explained in detail how to find the answers to those things. And what you'll notice also, I shouldn't have closed that, is that right here, I have my copies of the notes. I uploaded those for you so you could see my values. Additionally, if you go to Corpy World, which I think I've mentioned to you before, but if you go to Corpy World, you'll see that in his site right down here in chapter 6 section 2, this is his solutions of how he explained those. So if there was something in there that you did not follow how I did that, there are some tricky little things about calculator usage in there. You can follow his videos. He for some reason missed one of the problems, and it's not on there. The very last question is just not on his videos for some reason. You would not need to watch all of those by any stretch if you followed the notes, and you could kind of see what happens, okay? So that's just a quick synopsis of what you missed on Monday. And then today I gave students a little bit of time to start the little worksheet on that, which again, back in classroom, right in here, this is the actual worksheet that we did. And so you just have to watch carefully, because there's some things like, hey, only give me the answer that's in the first quadrant, for example. Or when you do this problem number 2, you'll notice that the curves cross, and so you want to do something, but it says, oh, let's find the area from 0 to 3. And so again, in Corpy World, you'll notice that if you go to Corpy World, this is the worksheet that we're looking at, and there is a key right here. So if you go to that key, not only does he have the answers there, but he shows specifically all the work that leads to that answer. Like I said, you'll see this little region that crosses, but they're actually asking for the area from 0 to 3 right in here. So that gives you a little bit. And I gave people a long time to work in class today, but additionally, we did something else. And so let me show you what we did additionally in class today. So I had them kind of sketch this thing right here. And this is a very simple square root graph. This is f of x equals the square root of x plus 2. And you should know that that is going to take that curve and slide it to the left 2 units. And so it's just sitting right there. And so rather than simply finding the area of this thing, we decided to take this thing into 3 dimensions. And so this is a little bit hard to write out exactly how this is stated, but we're going to find the volume of the solid. So it's going to be a 3-dimensional shape with cross sections that are circles. Perpendicular to the x-axis. And I'm running out of room to write, but I'm going to say bound between here, the curve, and the x-axis. And I did write all that out in class. I just kind of seems, I guess like I'm writing a little bit larger right now. So this is a little strange. So I'll kind of try to show you what this is. And I'm going to try to make the illusion of a 3-dimensional picture here. So I'm going to make basically a circle right here, and I'm going to try to make it look like it's popping out of the page. And so as I slide along this thing, you're going to notice that as these things move, their diameters are growing as it moves along the curve. And it hopefully gives you the illusion that the curve is getting larger and larger and larger as it comes, and it's like coming out of the page a little bit. Or at least if I was a better artist, that's what you would see. Sorry, I'm trying to finish lunch real quick. So what we're going to do, very much like what we did with Riemann sums, is we're going to consider one of these little pieces right here. And we're going to see if we can find the volume of one of these little pieces, right, like this. And that should look about like a coin, right? And if I could add all of those coins together, all those little discs, that would be the volume of the shape. And what I did in class is I said, let's just find the volume from -2 to 7. There was really nothing specifically magical about going from -2 to 7. I just picked it because it was nice and easy. So if we were to look at that little disc, that's a circle. So it would be a pi r squared would be the area of the circle times the thickness, which is going to be a dx. So a little trick there. Now what you're going to notice is in this shape, from here to here is actually not the radius, that's the diameter. So what I can see is that the diameter of the circle is y, which means y over 2 would be its radius. But what I gave you in the story is this is y. So the radius is going to be root x plus 2 over 2. So there's my radius, but it says pi r squared dx. And I want to integrate that all the way from -2 to 7 because I want to add up all those infinitely many little discs to come up with my story. Now, as such, something kind of nice happens, which is why I actually started with this exercise. If I take the square root of x plus 2 and I square it, I just get x plus 2. Remember, constants can pop in front, so I'm going to put this pi in front, and I'm also going to take the 2 squared, which is a 4, and I'm going to put it in front. And as it turns out, we've got a pi over 4, and I did this in class. You can do this. This is obviously a very, very simple integral, but this integral from -2 to 7 of x plus 2 is 81 quarters. So what, 81 halves. Just kidding, 81 halves. So the area of this thing would be 81 pi over 8. Excuse me, not area, but volume would be that. So simple little idea. Now, just to carry on with that idea, then I said, well, what if instead of dealing with cross sections that are circles, what about if we had square cross sections? So square cross sections I have found to be a little bit harder to draw. So keep in mind as those square cross sections kind of come out like this, we usually draw them kind of like that. I'm trying my best to make them look good, but this is going to look a little bit rough. And so you're going to see that we have this kind of a shape that is getting larger and larger and larger as we extend out. This kind of a fluted it's growing. So interestingly enough, if we just take one of these chunks right here and think about what that is, I know that from here to here is y, and I said it was a square. So this is also y. So that means the volume of this little piece right here is y times the thickness, which is dx. Well, turns out that's pretty nice because we knew that y was the square root of x plus 2 squared. And all of a sudden we got the same thing that we saw a moment ago, because we literally just did that problem up here. And so whereas the area, the volume, excuse me, of the circle was 81 halves times pi over 4, this one is just 81 halves. And what we can do, let me go ahead and see if I can find out where I put this. I put some extra pieces somewhere. Here is another one that we did in class where I said, well, what if instead of having squares or circles, what about if we had equilateral triangles that are growing and coming out of the page like that? So I just took one of these triangles right here and I placed it over here. So notice that this distance is y again, right? So I broke it down. Here's my dx. And so since this was an equilateral triangle, I know that all three sides are y, so that makes this 60 degrees. And so just playing little games that we did back from Math 2 and Math Analysis, if this is y, then this right here is half of y, and this is half of y times root 3. So when I went to find the, okay, so that was, again, this was y, so this is half of y, and this is this side times root 3 gives me the altitude. And so the area of this triangle is 1/2 its base times its height, and then its thickness is dx. So I just did a little bit of work, and lo and behold, that y squared popped up yet again. Of course, its area, it should. And so again, I pulled the constant out in front. I know that y squared is this. Hey, what do you know? That 81 halves popped up again and again and again. And so that's just a real quick look at something that we can do. And we started a problem in class and I got completely, I guess we just went too long and I didn't finish it. But you'll notice that this is in there and it was actually supposed to be a big part of what I did today and I didn't quite make it there. But it's a pretty big challenge for people to do the artistry on some of this stuff. I'm looking around to see if I have a copy of what I did. Your peers thought that their own graphs were pretty atrocious. So we'll end up revisiting this next Monday, and I hope that helps to make you feel like you're not as disconnected and that you're doing okay. So send me an email if there's any way that I can help you, and I'm happy to Zoom with you anytime between now and when class resumes next week. Have a great one. Bye.